current electricity पुढला टॉपिक और नेक्स्ट टॉपिक गॅलव्हॅनोमीटर. गॅलव्हॅनोमीटर is a device galvanometer is a device to detect or to measure weak current in the given circuit. Galvanometer is a simple device to measure very small or weak current in the given circuit. The construction of galvanometer is also very simple. The galvanometer is nothing but a coil. Say PQRS is the coil or number of turn wound over it, and this coil is kept or placed between two concave strong horseshoe magnet. The galvanometer is nothing but a coil, PQRS coil. This coil may be pivoted or suspended type coil, and this coil is kept in between two strong horseshoe magnet, and there is small pointer is attached. This is the internal figure of galvanometer, and there is a pointer, and also there is a glass window, and there is marking 0, 10, 20, 30, 0, 10, 20. This is rough or internal diagram of galvanometer. If this coil carrying current, this pointer get deflection and pivoted current, very small current, and indicate the figure 0, 5, 2 or so. This deflection of galvanometer is directly proportional to current in the coil. Current in the coil increases, the deflection of galvanometer is also increases. This is about the galvanometer. Such a galvanometer is applicable or used to construct another devices such as ammeter and voltmeter. Today we discuss about the galvanometer acts and ammeter. हा गॅलव्हॅनोमीटर एमिटर म्हणून कसं काम करतो हे आपल्याला आज पाहायचं आहे. द गॅलव्हॅनोमीटर acts as a ammeter. Today we discuss about the galvanometer acts and ammeter. Let coil of galvanometer, suppose whose resistance is G, and I is current passing through it. But a very small resistance called shunt, yes, very small resistance called shunt is connected parallel with the galvanometer or coil of galvanometer. That is, the current passing totally circuit is I, but current passing through galvanometer is suppose Ig, and current passing through this small resistance called shunt is suppose Is, and current suppose at point A current is I, at point B current is I. That means the total current in this circuit is I is equal to Ig plus Is. And this arrangement, a small resistance, that is shunt, connected parallel to the coil of galvanometer, then that galvanometer acts as a ammeter. When very low or very small resistance connected parallel with the coil of galvanometer, then this device ready to measure current in the circuit, and that device is called ammeter. This is the simple definition of ammeter. Very low resistance called shunt. Very low resistance called shunt connected parallel to coil of galvanometer, then that galvanometer is converted into ammeter. In figure, the total current I is equal to Ig plus Is. Therefore, we find out value of Is. Is is equal to I minus Ig, and Ig is equal to I minus Is, which is the total current in this circuit. Also, according to Ohm's law, the potential across this galvanometer coil and potential across the shunt resistance is same. That means the potential across the coil of galvanometer is current into resistance, that is Ig into G, or this is equal to potential across shunt resistance, whose resistance S and current Is, or this is equal to Is into S. But the value of Is is Ig into G, which is equal to I minus Ig into S. We get the value of shunt resistance. S is equal to Ig divided by I minus Ig into G. Using this equation, we calculate the very small resistance called shunt resistance. S is equal to Ig divided by I minus Ig into G, where S means shunt resistance Ig means current passing through galvanometer. I means total current in the circuit. Ig means current passing through galvanometer, and G means the resistance of galvanometer. Also, IGC, which is equal to IS into S, using this equation, value of IG, I minus IS into G, which is equal to IS into S. Therefore, we get value of G is equal to IS divided by I minus IS into S. This is the another equation, and using this equation we calculate the value of galvanometer or resistance of galvanometer. Using this equation we calculate resistance of galvanometer. Then we discuss about this shunt resistance. What is the use or what is the function of that shunt resistance in the given circuit? That is use of shunt resistance or use of shunt. The first use of this shunt resistance is it reduces effective resistance of an ammeter. This is the first function of shunt or first use of shunt to reduce the effective resistance of ammeter. Second, to increases this shunt resistance increases the range of instrument. The range of instrument. The third function or third use of that shunt is to provide the alternating path of electric current or excess current, and also to protect the galvanometer from damage. The excess current, to construct the path, to provide the path of excess current and protect the galvanometer from damage. This is the functions or use of shunt in given circuit. Now we discuss some cases. Two cases. The case 1, case 1, if the current I is n time to current H, that is I is equal to n into H, then the above equation, that is S is equal to Ig divided by I minus Ig into G, because put the value of R is equal to N into Ig. Therefore, S is equal to Ig divided by N into Ig minus Ig into G. Or S is equal to Igg divided by Ig into bracket N minus 1. Ig cancel. S is equal to G upon N minus 1. You see, first case, if we put I is equal to N times Ig, we get shunt resistance. S is equal to G upon N minus 1. Now case second. Case second. If Is current passing through shunt resistance and I minus Is is remaining current passing through the galvanometer or coil of galvanometer. The total current Is passing through shunt resistance and remaining current I minus Is is passing through coil of galvanometer. Then we get the fraction of current, that is Is upon I, which is equal to G upon S plus G. This is the two cases of this ammeter or galvanometer converted into ammeter. The galvanometer is converted into ammeter only if very small or shunt resistor connected parallel to the coil of galvanometer, and then such instrument to measure electric current, and that instrument is called ammeter.